Hi, my name is Courtney and I'm going to be talking about my Mesoporous nickel oxide catalyst for use in upgrading lipid-based biomass to diesel-range hydrocarbons. The motivation behind this work is the increasing demand of energy coming from the transportation sector, both in our country and all over the world. And so it's really important that we start developing um, alternative energies, and of these, biomass or biofuels have emerged as a promising option. So biofuels can be produced by taking oily plants like algae or the weed Trophocercus, extracting the oils and then converting these oils, which are fatty acids, carboxylic acids. You can convert them to long hydrocarbon chains, which is the equivalent of diesel fuel. Um, in the past, our group has studied zeolites, which are a silica alumina framework, microporous framework, and we've loaded noble metal catalysts or noble metals onto the framework, and that was used as our catalyst. Um, some of the drawbacks that we see from these kind of catalysts is they're really expensive with the noble metals, and zeolites can cause mass transport limitations because they have such small pore sizes. So in this work, we used mesoporous nickel oxide catalysts because they have high surface areas, giving the potential for high concentrations of active sites. You can control the wall composition of the pore, and you can, um, these specific catalysts, they're made from nickel, so they're much cheaper than loading platinum or other noble metals onto a support. Um, so these were synthesized using surfactant-assisted self-assembly. The surfactants that we used were pluronic P123 and CTAB. These are just long molecules that basically determine the size of the pore of the material. So once the catalysts were synthesized, we synthesized them based on a method that was used previously to make mesoporous gallium oxide. Once they're synthesized, we tested them in a batch reactor with oleic acid. Oleic acid is a simulated biomass molecule commonly found in algae, and that's why we chose that one. And we let it run for 4 hours, and the desired product is heptadecane, which is C17 hydrocarbon. Um, we confirmed that we made a mesoporous material through nitrogen physisorption isotherms, as you can see in the results section here. We know that we made nickel oxide from our powder X-ray diffraction. We tested the recyclability of our catalyst also, and you see some sintering of the crystals. Yeah, but overall, we've developed mesoporous nickel oxide catalyst with disordered wormhole mesoporosity. The catalyst that was synthesized with pluronic P123 shows high yield to heptadecane with about 63% yield. And an in situ reduction of the mesoporous nickel oxide catalyst results from the reaction's hydrogen atmosphere, which is why we see such high activity in the recycled catalyst as well. Let me know if you have any questions over email.